Jai Hind, my dear children. Today we are going to discuss about mobility of charge carriers. When a conductor is connected to the external electric field, electrons are moving with an average velocity called drift velocity. This drift velocity occurred per unit electric field is called mobility. Mobility mu is equal to drift velocity divided by electric field. So its formula is mobility mu equals E tau divided by m, where tau it is relaxation time. Unit of mobility is drift velocity is meter per second divided by volt per meter. Hence its unit is meter square volt raised to -1 second raised to -1. Now what are the limitations of Ohm's law? We know Ohm's law is not a universal law or fundamental law of nature. It has some limitations. Conductors which obey Ohm's law are called ohmic conductors. Example, metallic conductors for small currents. If a graph is plotted with voltage and current, the graph is a straight line. As voltage increases, current also increases proportionally. The conductors which do not obey Ohm's law are called non-ohmic conductors. This is what we are discussing now. Limitations of Ohm's law. The first limitation of Ohm's law is voltage V ceases to be proportional to current I. For small currents, a metallic conductor obeys Ohm's law and voltage and current is a straight line. So here in the graph, if a graph is plotted with current along the x-axis and potential difference or voltage along the y-axis, for small currents it is a straight line. That means it obeys Ohm's law. Then when large current passes through the conductor, we know the wire gets heated and hence its resistance increases and hence the voltage current graph no longer remains linear. So when the current increases, voltage increases, current increases and the wire gets heated up and hence the resistance increases, so it becomes a curve. So all conductors become non-ohmic at higher current. So that is the first limitation of Ohm's law. Now we move on to another limitation of Ohm's law. The relation between voltage and current depends on the sign of V. Here there is a device called a semiconductor device called the PN junction diode. The main use of diode is it converts AC to DC, and diode can be connected in two ways, forward biased and reverse biased. What are diodes? What are the characteristics and properties of diodes? What are the applications of diode? These all you will study in the 14th chapter, Semiconductor Electronics. Here I am just drawing the voltage current graph of a PN junction diode. So this is the graph. When voltage is plotted along the x-axis and current is plotted along the y-axis, so up to some voltage, for example, from 0 to some voltage, what happens to current? Current remains 0. After that, as voltage increases, current increases. So we can say that in this region, Ohm's law is satisfied. But here in this region, the beginning region, as voltage increases, current remains 0. So here Ohm's law is not satisfied. Okay, here in the reverse region, that is another connection of PN junction diode. Here as voltage increases, what happens to current? Current increases very slightly. After reaching some voltage, what happens to current? Current increases. This is the current. Current increases abruptly. Here also Ohm's law is not satisfied. So Ohm's law is satisfied only in this region. That is, voltage and current are linear only in this region. Okay. In all other regions, Ohm's law is not satisfied. That is, voltage is not proportional to current. So this is considered as the second limitation of Ohm's law. Now we can see the third limitation of Ohm's law, that is the relation between voltage and current is not unique. That is, there is more than one value of voltage for the same current. Here you can see a graph of gallium arsenide. Children, in the graph you can see for a current how many values of voltages are there? There are two values of voltage. Okay, so that means voltage and current is not unique in gallium arsenide. So these are the three main limitations of Ohm's law. Thank you.